Okay, great. So I'd like to introduce John Gibbs, also known as Dr. Know-It-All. And I'm Warren Redlick, as you probably figured out, since that's the name of the channel you're watching. Thank you all for being patient. So Dr. Know-It-All and I are going to talk about self-driving artificial intelligence, Tesla, and whatever else we come up with as we go along. Right. Is the volume... Okay, so let me just do a sound check. I don't think it's going to, audio is good for both of us. So I think most people know who I am. I am completely unqualified to have this discussion. My name is Warren Redlick. I am a lawyer. I'm not a very good one. Well, I shouldn't say that. I am a traffic and criminal defense lawyer and personal injury lawyer. So I've handled a lot of car accident cases and a lot of bad driving.
Okay, so wow.
So would you please tell everyone about yourself?
Yeah, I have a absolutely crazy background. My undergraduate degree is actually from Princeton in physics. And I unfortunately finished I wanted to be an astronaut. That's how this all started. In high school, I was going to be an astronaut. I didn't want to go into the military. So I decided to go into the sciences and go into physics, got into Princeton, spent 4 agonizing years being the dumbest kid in the class, really. So there's a lot of very bright people there. And I got done. Yeah, I heard you went to, was it Stanford Law School? Or
I was at Stanford Business School's PhD program, and I was the dumbest guy in the room.
So yeah, you know that feeling of going from the little pond of being the big fish to go into the really, really big pond of being the little fish. That was kind of it.
Yeah.
So anyway, so around, it was the late 80s, and I graduated and realized that the Cold War was wrapping up and that there was no chance, like astronaut, that whole option was really disappearing. And so I questioned my life. I had a little bit of a summer, and I went to graduate school in physics, which I'd been accepted to at Ohio State, but I switched over to the English PhD department and spent the next 6-7 years, whatever, working on getting a master's and a PhD in English. And then, of all the crazy things, I got a job. So now we move forward to the mid 1990s, when guess what's happening? The internet is starting up. And I ended up getting a job teaching English at a college, a little teeny weeny college in California Lutheran University. And they were just starting up a multimedia program, which was all the hot stuff back in the 90s, right? Everyone was like, multimedia. So I ended up directing that program, and sort of everything spun out from there. And I ended up getting into 3D animation, sound design, writing, which has to do with English too. But that's sort of what my sort of day job is. But then a few years back, when my kids got older, at University of Georgia, where I teach, you can take a couple classes a semester for free. So I was a glutton for punishment. So I went back and got a master's in artificial intelligence, which
let me just pause you for a second. I turned the gain down on my mic. Is our volume more equal now? Just asking. I'm going to look at the chats while you're speaking. I just wanted to say that so people can tell me if by lowering my mic, if it got better. Go ahead.
So yeah, just let me know, because I can adjust mine as well, of course. So anyway, so I got a master's in AI and have sort of been blending that back in again. I've got some publications in that area.
Hang on a second. I'm getting people saying the stream is down.
Oh no.
I'm getting a weird, like, everything I can see looks good. Live on custom streaming service.
Yeah. Are you using OBS?
No, you and I are fine. It's me. No, I'm not. No, with Zoom, I can't use OBS.
Oh.
Okay, no, I think we're okay. Sorry, go ahead.
That's fine. I don't know where we cut off. Like, you could ask people if they could.
No, it's okay. So let's just go ahead. I'm getting some messages from people that the stream is down, and it looks to me like my stream is down, but other people are saying it's fine. So let's just go ahead. So let's just go into the topic.
Sure.
So, and for people who don't know, Dr. Know-It-All has a channel called Dr. Know-It-All, or John Gibbs has a channel called Dr. Know-It-All, and it's in the description. In the video description, there is a link to his channel, and I would encourage you to check it out. He has some great videos. I wanted to talk about self-driving artificial intelligence, self-driving dojo. And I'm just going to introduce this with, I think there's a chicken and egg problem in what I'm about to say. I want to set the stage where we got a vehicle, we want the vehicle to drive itself. So here's the scenario. The vehicle is moving. Either the car is driving with human supervision, or the car is driving with human supervision, right? The human can intervene. or the car is watching the human drive in what's known as shadow mode. In-car software running on the FSD chips in the car, we're talking about Tesla, software applies weights from previous programming. And so that's a scenario. So the car arrives home, it uploads its data to Tesla headquarters. Maybe it starts with data on interventions and significant diversions. The headquarters of Tesla reviews data from all uploads. And I have a theory here that what it's looking for at this point is situations that require additional object labeling. There was an object that the FSD didn't recognize or wasn't sure of, and situations where all objects appear to be labeled properly, but still had some kind of intervention or diversion. HQ then identifies the difficult objects and it queries the fleet for similar situations. So this is sort of a rough introduction to the start of self-driving, is that the computer is driving the car and it has previous programming and telling it how to react to what it sees, how to decide what it sees and how to react to what it sees. And when there are issues, which there are probably every drive, some data is uploaded and then at some point HQ asks down. Does any of that sound close to accurate to what's going on?
Yeah, actually it does. I think you have to take a couple of steps backwards first, though, because I think I've always been a person who's been like, you have to understand what's going on inside the machine to really understand it.
All right, you start.
Yeah. Okay. Yeah. So, I mean, I'll liken this back to, I feel like I have an advantage with computer programming because I started so long ago that we programmed with assembler and stuff in high school. And so I have a better understanding of what really, a lot of people just look at their phones and they're like, it's magic. But it's actually just code. So this neural network programming is very, very different than what you might think. If you're a traditional computer programmer, if you ever took just a Java class in college or something like that, you're used to like you define the problem, you write a few lines of code or thousands of lines of code.
If child in front of car, stop.
Yeah, I mean, and that my understanding is that full self-driving software 1.0 was that, more or less. It was just a whole laundry list of rules. And so, of course, it still had to identify, is that a child or not? And that's not the easiest thing in the world to do, right? Because, sometimes a person's walking on the side of the street with black clothing on and it's really hard to see them at night, etc. So that's not a trivial matter whatsoever. But you also have this laundry list. But the problem is the laundry list is almost infinite. It will just keep on going. There's always another case of something. And so you'll never get done writing the code because there's always something else that's going to come up if every rule is rigid. So a neural network model, which is the software 2.0 that Andre Karpathy talks about, and he kind of likens it to like software 2.0 is eating software 1. So it's taking over role by role. That is completely different. It's a neural network, which instead of a bunch of hard, fast rules, is what you were saying with weights. It's a whole bunch. You have an input, which is your images, and you have an output, which is stop the car or turn 2 degrees to the right or whatever. At every instant, there's an output decision that's being made. And in between that is thousands upon millions of little teeny weeny nodes that are all extracting features from the situation that's going on and making a decision about that and passing it to the next layer. So you might have 12 or 18 or 24 or 30 layers of these hidden things, and they're connected together. And all of that, of course, what they do first is they and the reason why you were talking about being in shadow mode or having an intervention, why that's so important, is because the way that you train a neural network, it's not hard coded. You don't say if this, then that. You say, here's my input, here's what should be done as the output. You go have some fun and you tell me if you get the same thing. And if it's right, everything's good. But if it's wrong, then you kick it to the curb and you send an error message back through the entire network. And with some pretty complicated math, you figure out what each of those weights has to do in order to fix itself to get better than what it was doing. So this doesn't work on 2 examples. This requires millions upon billions of examples, which is why a computer like a supercomputer like Dojo is going to be so critical, because the faster you can crunch through all of this data, the faster you can train these things, because number one, for neural networks to work, you have to have a ton of data. And number two, you have to have a ton of processing power. But if you have those two things and you have high quality data and processing power, you can loop this around and around and around again until you get to a situation where the network actually has learned, but it doesn't learn explicit rules like if child in street, move out of the way. It's like if a situation like this arises, which is kind of more fuzzy, then do this. And so that allows you these situations of, if it could be a little girl in the street, or it might be like a guy with like clothes on, or it could be a trash can in the street, whatever. It allows it to deal with these situations.
Well, wait, let me disagree with you for a second. And,
sure.
When I disagree with you, I recognize I'm probably wrong. Okay. From watching the the first Jim Keller interview with Lex Friedman, my impression is that the first thing it does is identify objects, and then it assigns ballistic probabilities to each object. Is this object moving? Is it not moving? If it is moving, where might it go? And it sort of like creates predictions about where objects will go. And the goal is to avoid crashing into any object. And then it may at some point prioritize, well, it's okay to crash into this object, and you definitely don't want to crash into that object. But I think generally speaking, the goal is to take the path that minimizes the risk of colliding with an object while at the same time taking a path and going somewhere.
Right.
So I don't think it's there's a child in the road, don't hit it. It's here's all these objects. What's the path that's going to minimize the risk of hitting anything?
Right. And that's what actually, we're kind of agreeing with each other, because what I was saying is it's a fuzzier thing. You no longer have if then rules. It's sort of like whatever you kind of see along the road, inside the road, whatever. It doesn't really matter, particularly what that object is, once you've assigned it a ballistic probability. You're absolutely right, because it needs to know the difference between a dog and a garbage bag.
Yes.
Or a garbage can or a smart car, or, because sometimes,
yes.
But so it could, because a smart car can move, and a garbage can, unless it's a hurricane, is just going to sit there. So,
well, and over time it may develop like a pedestrian walking on a sidewalk is probably going to continue walking on a sidewalk.
Right.
A dog that's running around might run out in the street.
Right.
And it might have a different set of ballistic probabilities for a dog running around, even if the dog's on the sidewalk, than the human walking on the sidewalk. And it still has some probability that the human's going to walk out on the street.
Right. But then there's also, it just sort of implicitly learns physics too, because let's say a person is 2 meters off the road where you're driving and they're walking parallel to you. There's a certain, like, inertia takes a certain amount of time for them to turn and head towards you. Right. So it's going to take, say, a second or a second and a half or 2 seconds for them to alter directions and move out there, at which point your car might be past it. So if it learns that rule that a human being with a mass of 70 kilograms or something can't just instantaneously hop out into the street, where what you're saying, like with a dog, of course, because a dog's not generally walking so parallelly, it's may do whatever random thing. So it's probably going to be much more aware of a dog on the side of the street than it is a human being, because there's expectations. But what about a child? What about a 3-year-old? Kids are stupid, sometimes kids just run out in the street. So,
right.
So it needs to recognize all of those situations. And like you say, the most critical thing is don't crash into anything. Don't hurt the driver, don't hurt the car, and don't hurt anybody else.
Right. No, but I think there's a step in the way, which is, there's probably more steps than this, but one step is recognize objects. Right.
And that's super hard.
Right. That's a challenge. That's what Andrei Karpathy is supposed to be particularly good at. That's what he's been focused on. For those who don't know, Andrei Karpathy, I mentioned Jim Keller before. Andrei Karpathy is basically the head of the self-driving program at Tesla. And Jim Keller, I mentioned before, is a chip designer who worked at Tesla. I believe he worked on the current, I don't think he finished his work, but I believe he was working on the current generation FSD chip that's in the car. And he may have had some work related to Dojo, the Dojo chip, but not a lot. Does that sound right?
Right. Yes, that's correct.
So you've got recognized objects. There may be another layer of recognized events, which is something maybe we should talk about. But there's also assign ballistic probabilities and then choose path. Right? Are there layers I'm missing? Are there parts of that I'm missing?
Well, one of the really, really hard parts is that the road system that we've got, there's, I think I did several videos actually trying to explain Andre to the masses, because, he gets into these conferences and talks at a pretty high level.
Yeah.
But he talks specifically at one point about stop signs. And he's like,
Yeah.
okay, so a stop sign, fine. But what about a stop sign that's partially occluded by a tree? Or what
Yeah.
about a stop sign underneath one of those orange sodium lamps?
Wasn't there one that was on an arm of a gate?
Yeah.
And when the gate went up, the stop sign went up with it.
Right. Or a human being. Like, what about the person at the side of the road who's holding the stop sign and then they drop the stop sign and that means don't worry about it. So, but then there's things like stop unless you're taking a right-hand turn, or stop unless you have the right of way on a single lane bridge. You know, there's all kinds of crazy things that happen. And so it's essentially the neural network is by itself learning to categorize. It's sort of classifying, I guess would be a good way to put it, right? So it learns, here's a whole class of things called stop signs, and here's a whole way that they can look. They can look all kinds of different ways if it's raining or snowing or light, or they're partially occluded by something, or blah, blah, blah. And so these are all stop signs. And then there's modifiers on the stop signs, like modifier being a human being holding it up or holding it down, arm holding it up or down. The little signs that have four-way stop, two-way stop, except on right, et cetera, et cetera. So it subclassifies and subclassifies and subclassifies. And for each of those different subclassifications, it's like, well, is my path to make a right-hand turn? Oh, I see a stop sign, but the stop sign says except for on right. Therefore, I'm okay with continuing on going.
Let me just pause you for a second here. So the car's out driving and it sees a stop sign it hasn't seen, that the software is unfamiliar with. And it gets back to the home and it uploads data and it says, hey, I didn't recognize this thing today. I think it was a stop sign, but I'm not sure. And they query the fleet and they get a whole bunch of photos like that. And is that where a human labeler comes in and says, this is this type of, do they have to assign it? Do they not have to?
I think their goal, they talk about Operation Vacation all the time.
Yeah.
And I think that we have the way that it has been done and the way they want to do it. So the way that it has been done, and believe me, I've done this myself for my own research projects, is it's a torturous process. You label the images. You go through and you go, stop sign, stop sign, stop sign, not stop sign, stop sign, stop sign, stop sign with modifier. And that just takes for bloody ever, right? But the way that they're trying to do this is to sort of automate this process so that they're saying, especially if it's a kind of intervention event or something where something goes wrong and they get it flagged, and then they look at that data and they're like, oh, a human being will probably look at that and say like, oh, I see, this is a problem because it's a stop sign that maybe it broke, like maybe it's tipped over sideways. So it didn't recognize that. So now what we can do is they build a little mini training system to train it just to recognize stop signs that are bent over at 45 degrees to the right or something, right? As an example. And then they send that out to the fleet and they say, anytime you see this, so they have a little mini piece of software out there that goes around and all it's doing is looking for bent over stop signs. And hopefully, even though that's a weird edge case, hopefully they'll bring back a couple of 100 or 1,000 or whatever cases from around the world, at which point they then stick that into the machine and they train and train and train on just that specific thing so that it learns how to recognize that particular bizarre edge case.
Right. Okay. So that there's the vision part, which is recognizing objects. I'm sorry, I was looking for a tweet. Elon tweeted something about AI the other day, and I can't find it, and I replied to it.
Oh, it is impossible to find. He tweets so much, I can never find it.
No, but I had replied to it, and I asked James Doma to explain it, and I was going to ask you to explain it, but now I can't find it.
Okay.
So I'm getting all these. Oh my God! Stop. Stop.
Is it all the live chat stuff?
No, I think I created this meeting 4 times and my calendar alerted me of the meeting 4 times. There's a 5th one. I know.
It's forever going to tell you that you've got a meeting now.
What happens if I click this button?
Gosh, I wonder if I could find the tweet, but there's no way. I have a bot on my Discord channel that kind of just pops up. Do you remember what it said?
No. No, that's why I was trying to figure it out.
Yeah.
So, all right. I'm sorry. I apologize.
That's fine. No big deal.
So it was just something in my head that he asked him something I wanted Doma to explain. So there, one of the challenges is identifying objects. What about this idea? So there's the vacation idea is instead of humans having to label stuff, I guess what I would say is there's this scenario called shadow mode.
Right.
In shadow mode, the human driver is driving and the AI is watching. And the AI is doing, I'm going to say, two particular things.
Right.
Okay. The first thing is it's doing, and this is what it's doing when it's driving also, is it's watching all the objects in the road. It's making ballistic probability projections. And then if something doesn't move within the parameters it expects, that's something it might send to the home office and say, hey, we've got to learn from this event. But it's also watching the human driver. And it's watching, and they've identified the best drivers, so it's watching the best drivers. And it's looking to see if the best driver diverts from, it's projecting the path it thinks the vehicle is going to take. And it's looking to see if the driver does something different from what it predicts. And that's not necessarily, and then of course there's, if it's driving and the human intervenes, that's another type of thing. But I think these are all things that it would send up to headquarters and say, hey, take a look at this. Does that make sense?
Yes. And that's exactly what it's doing. Because the problem is, they have, I think, 3-4 billion miles worth of driving at this point.
Yes.
And a lot of that is useless at this point. In fact, actually, William Lee, the CEO of NEO, has been on Tesla's case. Or no, sorry, it's actually Mobileye. Not anyway. Is his name Shashua? Anyway, the CEO of Mobileye has been all over Tesla.
He's an Israeli guy.
Yeah, they say he's like, they've got all of this useless information and they're just training on nothing. And so therefore our system is better. And I'm like, no, I don't think that's the case, because it sounds like what they're doing is they're calling out specifically instances where the car makes a prediction in shadow mode. And it says, I need to turn slightly to the left, and the driver turns slightly to the right. And so it's like, why was there a differentiation? So that's what I'm talking about, that feedback loop where there's a predicted output. So the ground truth predicted output is what the driver does, and the computer then has to go back and fix itself since it made a bad prediction. But then also, of course, interventions where the car is driving itself and a human goes like, and you have a Tesla, right? So
no, I don't. I've driven Teslas, but I don't have one.
Okay, so it's a pretty common occurrence. I don't have the beta, which is obviously way better, but I did a 20-minute drive so 40 minutes on the road today. And in that time, well, first of all, I'd say like probably 20 minutes of that is self-drivable because some of it's on back roads. But anyway, on the self-drivable part, I probably had 3 or 4 interventions. And so hopefully what's happening is those little pieces of data are being specifically shipped to Tesla, and their computing training giant supercluster thing is looking at that specific data, because that was stuff. There's one specific spot where I drive where there's a street that comes in. So you've got this street and you've got the street coming in, and there's a stop sign on the corner of that street, but it's facing out towards our street. So like my main street. And
I was thinking of that situation.
Yeah. Every time the car slams on the brakes and I'm like, so yeah. It's not, it's like, that is a situation where their intervention is needed, because it's not recognizing the fact that the stop sign is canted away and it's not my stop sign.
Right. Yeah. So well, I think a key point about having all the data is there's a lot of data of driving on highways when there's nothing happening. And that particular data is not terribly useful. But the point is, when you have billions of miles, if you have billions of all driving data, if 1% of it is useful, right, then it's better to have billions of miles than millions of miles, because you have 1,000 times as much useful data. And I think part of it is, Elon refers to it as the March of Nines, that you solved highway driving, and then you've solved this other thing, and you've solved this other thing. At a certain point, you get to the point where the FSD or autopilot or whatever can handle 99% of everything. And then it can handle 99.9% of everything. Right. And the more it can handle, the smaller percentage of your data is useful anymore because it's already handled that. Right. And you start to get to these real edge cases where, okay, there's a cow in the road.
Right.
Right. Which it probably has already handled a cow in the road. Or as he says, a UFO lands in the road. It has to identify every edge case. And then I think, well, I wanted to get to this point where we've talked about the human labeler. It sends up this data, these images or whatever, and human labelers say, okay, this is a cat, this is a stop sign, whatever. But there's another level, and I don't, maybe I'm jumping ahead too much, but there's another label that I don't really, I'm going to confess right now, I don't get this. It's like self-supervised learning, right? And so there's a contrast, whereas one, it's sending all this information up and humans have to label stuff and say, this is this, and maybe they have to intervene and say, you need to handle it this way. I don't know how much they're telling it how to handle things, but it's helping it identify things. At a certain point, you get to self-supervised learning, which I've tried to understand, and I'm pretty sure I don't fully get it. So can you give a short explanation of self-supervised learning?
So, well, that's Operation Vacation right there. If they can get it working right, it basically means the machine trains itself. So, I mean, supervised learning is a pretty easy scenario. That's you're the student in class, and you've got the teacher, and the teacher says, "What's 2 + 2?" And you say 6, and the teacher goes, "Whack!" You know, it's a bad teacher. Teacher hits you with a ruler and says, "No, that's not the right answer." So you try again until you get to 4. That's supervised learning, where the teacher is the human being. The problem with that, of course, is that computers are way, 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 way faster than humans. And so the computer's sitting there just spinning its wheels, waiting for the human to give an answer.
Right.
Okay, so that's slow. So ideally what you would have is the computer be the teacher and the student, but that's really, really hard, because if the computer is learning to understand what 2 + 2 is, how can it give you whether it's the right answer or not? So this is where that ability to utilize human beings is very valuable, because if what it's doing is it's saying every time there's an intervention where a human takes over from full self-driving, or every time it's in shadow mode and it makes a prediction that's wrong, right? The human being does something else, assuming the human is correct, which is not always the case, but it's worth looking at. And then if it comes up and it doesn't slow down for a stop sign and the human being slams the brakes on, you know, what's going on there? So it needs to be able to grab those examples. And even though the computer doesn't know what those examples are and what's wrong with it, but it can take that because it knows something's wrong. And so it can utilize that, even though it doesn't know what the right answer is, it knows it's wrong. And so it's much more, supervised learning is much more straightforward. Unsupervised learning is much more complicated, because you're having to basically allow the thing to teach itself.
Well, let me ask you this. Are you familiar with Comma.ai?
Oh, yeah.
So my impression is that George Hotz, for those who don't know, Comma.ai is a sort of self-driving, I don't want to say competitor to Tesla, but George Hotz came up with this idea. He basically took an Android phone, stuck it and put it up in place of the rear view mirror inside the car, used one camera, and it does lane keeping and it does emergency braking and a bunch of other things. And you can install it in a lot of varieties of cars. And my understanding is George Hotz doesn't do labeling, that it's supposed to learn. I don't know if it's self-supervised learning in the same way, but the software is training itself based on the human behavior it observes.
Right.
Are they doing self-supervised learning? Or are they doing something else?
Well, it's kind of a strange hybrid. There's also semi-supervised learning, which is partially human controlled and partially computer controlled, which is probably a little bit more accurate. But the problem is that human beings are actually giving feedback to the computer because the drivers are doing it. But the deal is the people that you're paying don't have to do that. Right. So
so the driver interventions are, well, you don't want the feedback to be crashed. Don't do that again.
Exactly.
That's not the feedback you want. So let me ask you this, because related to this problem is, and by the way, if you check the description below, I have links to my t-shirts and my Patreon, and I'm mentioning my t-shirts, and I'm wearing the best part is no part t-shirt. Are you wearing, is that merch you're wearing?
Yeah. It's my Tesla bot shirt.
Okay. So, and that's something they can buy from your channel?
Yeah. We both have an all input is error t-shirt, I noticed.
Oh, I didn't know you had one. Okay. So
yeah.
I'm going to guess you thought of it first, because I just created that shirt. But that's what I was getting at, is I just created a shirt called All Input is Error. His probably looks better than mine. I'm not really satisfied with my design. But so you get to a point where Elon has talked about this. He thinks this year FSD will be better than human. And there's an interesting question here, which human, which I can talk about in a minute.
See, this is where your area of specialization is going to come in handy here.
Maybe. But at some point, it gets better than all humans, but we still want it to be better. So how does it learn once it's better than human? It can't learn from the human drivers anymore. You know, the all input errors point is, if it learns from human disengagements, and as Elon says, all input is error, then the human disengagements are wrong. right? Like
Right.
maybe the car starts swerving to the left and the human thinks, no, don't swerve to the left. And the car is swerving to the left because it saw something on the back right coming towards it that the human didn't see. Once it gets good enough, there is no value in having humans tell it what to do. It's better than human. Does that sound right?
Yeah, I'm actually put in mind. Do you know about the Imagenet challenge?
I've heard of it, but tell us about it.
All right. So the Imagenet challenge, it was, oh gosh, I can't remember the year it was created, early 2000s. But it's about 1.3 million pictures, and there's 1,000 categories of images. So like dogs and cats and French horns and just mountains and whatever. And so the deal is that very laboriously human beings labeled those 1.3 million images, bunch of graduate students, because that's what grad students are good for. And so they created this thing. And at the time, this was before neural networks were really.
Yeah, sorry, just for people who don't know, graduate students are also known as serfs.
Yeah, exactly.
Somewhere between serfs and slaves.
Exactly.
Okay. Yes.
It's a sad reality, but it's true.
Yeah.
But anyway, so they created this thing, and at the time there were things like support vector machines and k-means clustering and all sorts of more traditional AI techniques that were being thrown at these problems, and they were coming up with less than 50%. So if you threw a picture of a dog and a cat at it, it was like toss a coin whether it was going to guess right or not. And so then in 2012, oh my gosh, not Jan LeCun, Jeffrey Hinton. Thank you. Jeez. I'm so bad with names. I don't know why names always like elude me. But anyway, Jeff Hinton and his team created the sort of first deep neural network that was utilizable. Now, he had been researching this stuff in the 80s, but he was just ahead of his time because computers and data just were not good enough.
The hardware wasn't ready.
Yeah. And also just data. I mean, you couldn't digitize pictures back then. It literally was impossible. So anyway, so he had this, and he had these networks that he'd started working on in the 80s and was laughed out of the room about. But he came back, and man, with a vengeance. And so suddenly, I'm trying to remember the exact number, but I think they went from like 52% accurate with the best possible previous techniques to like 84% in 1 year.
Right.
So it was just like people's minds exploded. And now in that specific challenge, computers are significantly better than human beings at doing that thing. Right. So in other words, if I threw a bunch of pictures from that thing at you, you would have a bigger chance of mislabeling one of those images versus the computer.
No, and in fact, I think it's actually common now in radiology, like interpreting X-rays, MRIs, right. A lot of scans that doctors do, that the machines are better than the doctors. Right. Yeah. And then the doctor takes the machine's interpretation, and then he has to apply some human judgment to it at this point. Right. They don't just let the machines diagnose you, but
but they're also faster. I mean, as opposed to having a technician look at these slides one at a time and potentially make a mistake because they want a coffee break and they're tired or something.
Yeah.
These machines can process thousands, a day. It's like chung, 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 and they just go on, and they make way fewer mistakes than human beings do. So this is amazing because it's expert knowledge that's being built into these neural networks, whether you're just a human being that can recognize pictures, or a cancer oncologist who is looking at images of whether it's cancer or not, things like that. This sort of expert domain knowledge is being placed into these networks, which includes driving.
So let's get back to this. There's this question I have. I think we need to explore this point because I saw a couple of people comment on it in the chat. There's this question about once it's better than human. So let's address I want to address the better than human concept first. Right. And I don't know if you've heard me talk about this before. So, of course, I'm a really good driver. I'm better than average. I'm much better than average.
Are we all in Lake Wobegon?
We could go if we went there. I have a whole story about Lake Wobegon, but I saw somebody comment, every driver thinks they're better than average. And see, I live in Boca Raton, Florida. Here, half the children are 98th percentile. It's a variation on like, well, we have Boca Wobegon, but we do sort of somewhat objectively, we are able to categorize who's a good driver and who's a better driver and who's a worse driver. And basically we can do it by driving record, right? Somebody who has a lot of tickets is probably a worse driver than somebody who has no tickets. Somebody who has a lot of accidents is almost certainly a worse driver than somebody who has no accidents. And I think Tesla is able through its software to identify who's a better driver. But when Elon says 200% better than human or 300, I'm not really sure how what the 200, 300% means. Are we saying, I think we're saying 200% they have half as many accidents per mile, and 300% they have a third as many accidents per mile. But my question is compared to which driver? And I'll just, this is a philosophical point maybe, but I think this is actually a practical point. Let's suppose we have drivers from 99th percentile to first percentile. The 99th percentile are the best drivers. They're better than 99% of the drivers. And the first percentile are the worst of all the drivers. The worst, they're only better than 1% of the drivers or whatever.
Right.
If you had a system where, let's say, full self-driving comes in and it's 30th percentile compared to human, but it only replaces everyone below 30th percentile. If you were able to set up your system, and I believe there are mechanisms that make this more likely than you would think. Okay, if it's worse than average, it's worse than the average human, but it's better than 25% of humans, and you put it in and you take that 25% off the road and make them ride in robotaxis, then you've made us all safer. And this is another thing, people probably don't realize this, but the worst drivers cause a disproportionate share of the accidents. So if you just take off the bottom 20%, so in other words, if it's 40th percentile and you take off the bottom 20%, you've made us a lot safer. You've eliminated more than half the accidents, even though you've only taken 20% of the human drivers off the road, and you've replaced them with a below average driver. And some mechanisms for this are, well, people with drunk driving histories pay more for car insurance.
Right.
This is going to offend people, but people with bad credit histories tend to be more likely to have accidents, and they tend to face higher insurance rates and higher interest rates for buying a vehicle. So the people at the bottom of the percentile list, it's probably more expensive for them to drive than it is for people who are better drivers. You know, there's exceptions to this because people who are better drivers might be richer and afford more expensive cars that cost more per mile in terms of depreciation or whatever. But I believe it is I'm not saying it's a perfect thing, but I would say it's generally true that the worst drivers pay more to drive. And for people who don't know this, I'm a drunk driving criminal defense traffic lawyer. I'm not a criminal, but I've at least never been convicted. But you know, I've certainly had my share of tickets, not recently, but you know, I can tell you that people who get a lot of tickets pay more for insurance. People who get drunk driving convictions pay more for insurance. People who have bad credit histories are more likely to get in accidents, and they pay more for insurance, and they pay more for financing. So if they're spending more per mile and you introduce robo-taxis that cost less per mile, they're more likely to switch. Yeah. And also teenagers, right? I have a 19-year-old and a 16-year-old. And the 16-year-old is not licensed yet, but will be probably in 6 months or something like that. I don't think I'm pretty confident I'm a better driver than them. And I'm pretty confident their mother is a better driver than them. Not sure about their grandmother, but that's another conversation. Definitely not my mother. My mother is definitely not a better driver at this point. My mother has Alzheimer's and lives in an assisted living facility. So she had her car taken away a while ago. Whole separate question, by the way. Would my mother pass a Turing test? Maybe we can cover that later.
Oh my goodness. Oh my goodness. That's
would a dementia this is going off on a topic. We should talk about this sometime. Would dementia patients pass a Turing test? But well, that's way off topic. So if you took teenagers off the road, because like if you look at the numbers, like 17-year-old male drivers at night with kids in the car with them are roughly 10 times as likely as a 35-year-old male or female. You know, there's a certain group of people who have very low accident rates, and there's a certain group of people who have very high accident rates. And teenage drivers have very high accident rates. You know, the first few years of driving, there's a lot to learn. They haven't gotten all the data. They haven't had the self-supervised training operating long enough. They are, in effect, neural networks, and they're better than in some ways than computers at this. But if it was done that way, if you were able to make, even if it's not like by design, but it's just by incentives, it would make us safer. And so I actually think there's a political reason why you have to restrict self-driving cars. Yeah. But from a practical standpoint, though, once it gets to somewhere near average human, whether it's 25th percentile, when it's a second or third percentile, yeah, it's not ready to go.
Right.
But if it gets to the point where it's 30th percentile, 40th percentile, 50th percentile, I would say once again, look, we let the below average drivers drive.
Right.
Right. We're, like I have a 19-year-old and a 16. We let my 16-year-old drive with a human supervising. Right.
Right.
And when that kid gets a license, they're going to be able to drive without a human supervising. We let that person drive, even though we know they're more dangerous. We know they're not as good as average.
Right.
By the way, my kids, of course, are very good drivers.
They're above average.
Not as good as me. Not as good as they're 75th percentile. I'm 99th percentile.
That's always the case.
Yeah.
They're not actually,
75th percentile.
If one of the amazing things about computers is, so I still to this day honestly don't know whether we're ever going to solve full self-driving. But let's say tomorrow it clicks. All it takes is one computer. After that, it's done.
Well, they all do it. They all get it.
Yeah, we don't have to teach the 16-year-olds anymore how to drive, which is what you were saying. Those first 3 years or so of driving are I've got a 20-year-old and a 23-year-old and a 27. Yeah. But those first couple of years, you're just going like, oh, please don't have an accident. Please don't, don't get a ticket. Don't have an accident. Well, when
you're teaching them to drive, what I've noticed is kids don't see down the road.
Yeah.
They don't. It's kind of like, the computer has to pick up objects and identify ballistic probabilities. I'd be driving with my kid and like, did you see that bicycle a quarter mile up?
Right.
I'll see a bike. I'm not worried about looking what's right in front of the car. I've already seen that. You all right?
Right. Yeah. Just drank tea incorrectly. Sorry.
See if you had an AI drinking for you,
it wouldn't make a mistake.
It wouldn't make these mistakes. They would have learned from that mistake the first time.
Exactly.
So I think there's a lot of things that teen drivers don't get. One of the particular things is they don't see the road the same way that we do. They don't see objects. They're not capable of us. We don't consciously assign ballistic probabilities, but we subconsciously assign ballistic probabilities. Right. And they aren't able to do that in the same way. And then, they don't know what to do in a roundabout. They encounter a difficult situation. But I think your point is really good. Once it learns it, they all get it. Right. It gets uploaded and downloaded and they all get it.
So like if you get a car that gets to the 50th percentile, all self-driving cars are 50th percentile after that.
Right.
So you suddenly don't have all of those. You don't have the other cars trying to catch up. It's like they're just like boop right across the board, 50th percentile.
But so there's a certain point where it gets to 75th percentile, it gets to 80th percentile. I think Elon wants it to be 99th percentile before he lets it roam free. And maybe he wants it 99.9 percentile, but he wants it somewhere up high. Because once you get over 50th percentile, there's a lot fewer accidents, but you get over 80th, 90th percentile, the accidents get really rare. Right. So I guess my question for you is, when it gets to the point where it's better than human, as in 99th percentile, and input is error, right? Human input becomes error. How does it get better from there? And can I offer my theory first, or do you want to take it?
Well, let me take it first, and then I'll hear your theory. I think that the way it gets better is there is a ground truth to driving, which is
explain ground truth.
Okay. Oh yeah. So ground truth. All right. So let's just take an easy example first of a picture of a cat. It's an obvious picture of a cat. That's ground truth. Like you can look at it and you can say, this is a cat. It's labeled a cat. The computer doesn't know that when it's training, but the ground truth is the thing that you teach it from. Yeah. So it says snake and you go, no, that's a cat. And then you send it back and it learns. So the ground truth in driving is there are some pretty basic metrics. Don't smash the car. Don't hurt the person who's in the car, driver or passenger, and don't smash anybody else. So, those are so there is a ground truth, and the car, even if it's 99.9 percentile, will still make mistakes if it's driving billions of miles. So when it makes those mistakes is when it can still learn. Because it's what did I do wrong?
So I mean, I guess one theory I have, where I was going with this is the car's driving down the road and it's assigning ballistic probabilities to objects that it sees, and it's choosing what path to take. And let's say 6 frames later, something that it predicted would be, maybe it had a bubble, it had an area that it thought it would be in, something goes outside of where it was predicted to be. Or it thought it directed the car to go on a particular path and the car didn't go on the path that it told the car to go this path and it didn't go where it said,
Right.
which maybe it hit a patch of black ice or who knows.
Right. Or a pothole or something.
Yeah. So is that's even if it doesn't crash into anything,
Right.
this is the point. It's not crashing anymore, but something doesn't happen the way it predicts. And that's a learning opportunity. And then it sends that data back to Dojo or the home office or whatever. And then there's some learning process from there. Does that make sense?
Yes. And that's what I'm talking about. The ground truth. I was being excessive saying it would just smash into things. But if it says the correct path because I saw a dog over here was to continue going straight, and then the dog darts out and it has to make an emergency maneuver, even though nothing bad ultimately happened, that's a big mistake on its part. And it can still learn from that, because it can be like, oh, I better, if the box I put around the dog was this big, I better make the box this big next time, because you never know, it might go
right.
ballistic. Yeah.
So the box you're referring to, if we're looking at the Tesla screen, the screen in a Tesla, it puts boxes around objects. Are the boxes sized to indicate ballistic probabilities, or are they just, I didn't think the boxes were designed for that. Maybe it has a box in its own understanding.
Yeah, I think this is more of an internal thing. I think the display is only just showing us, it's saying like, this is a car, this is a person, whatever. In the current version that I have that has the more fancy graphics, like today I was driving by a person on a bicycle. Actually, they were on a weird little scooter, but it showed a picture of a person on a bicycle. Right? So, but it's obviously identifying that as a bike rider. But within that, internally, it needs to have a safety zone. Right. Which is like, how far away do I have to get? Like, what if the cyclist just turns into me? I better get the hell over or slow down or something. So, but
let's say it has this moment where it's driving down the road, and probably has more than one a day or whatever, where something doesn't comply with what it predicted. Right. And it sends that up to the home office, and then the home office queries the fleet. Anybody else experienced this with this particular type of object? And the system is able to train itself. Okay, we need to update our ballistic probabilities for this type of object. Does that sound like what it? Not that there's a conscious, not like it's a conscious decision. We're not talking about somebody making the conscious decision, but it's just it back propagates. Is that the right way of thinking about it?
Well, it flags the error, and the back propagation is actually a way of doing the internal training. I think probably for the audience, it would be helpful to understand your car doesn't learn. It may have some very basic stuff that it learns, like, oh, there over here is a stop sign, like, in the neighborhood, but it's not doing the training. What's doing the training is the mothership. You keep saying, the headquarters, it's whatever it is at Tesla, it's going to eventually be Dojo, but right now it's just a big supercomputer cluster.
On that point, somebody had a video where he's driving the car. There's this particular spot where the turn is past something and the car turns in the wrong spot. And he goes around he fixes it. He goes around the block again, and it doesn't quite get it right. And he does it a third time. This is all in the same, half hour.
Right.
And the third time it gets it right. And he thinks it's learning. And other people were saying, no, the circumstance, there was a car in front of it that it followed the third time. It had a role model to follow. And it's not even necessarily a role model, but it's just, it had different inputs that you didn't understand. And if he had done it a fourth time, it probably would have done it wrong again. Right. It didn't learn. It didn't teach itself how to do that intersection on its own. Is what you're telling me?
Well, I wouldn't. The problem is that we, of course, don't know the ultimate answer to this. I think there's a small amount of memory. I've just noticed, for example, that in my neighborhood, after driving my car for 3 months, it's better at dealing with stuff in my neighborhood. So I have a feeling that it's memorizing. There's probably some small amount of memory that it has, that it's like, if I pass by this place, it knows on GPS, like on the maps, it knows this spot, and there's actually this weird little turnout or something, and ignore this, right? So it messes up the first couple of times, but then it can memorize that. So simple stuff like that, like just kind of memorization. I think that it's actually doing that, although I don't have any proof of that. But in terms of like really training and getting substantially better and a new version of the model and stuff, when they give you that software update 43.8 or whatever, that's a whole new thing that the computers back at the mothership have been training on.
Okay, so let me ask you, I'm going to change the topic a little bit. The current generation of Teslas have an FSD chip that used to be known as FSD version 3, but is now known, according to Elon, as FSD version 1. I don't know why he changed the designation. I don't know if you saw this.
I didn't even see that. Okay.
Yeah, so he said it's version 1, and I think it was Sandy Munro, in the Sandy Munro interview. He asked him about the version 2 chip, which they had talked about at Autonomy Day, that there was a new version of the chip coming. And Elon basically said to Sandy, and at Autonomy Day, Elon said it's going to be roughly 3 times better in all reasonable metrics. And so Sandy Monroe asked him about it, and Elon said, well, the current generation chip is nowhere near its limits. So we're not really worrying about the second generation chip yet. And when we go to the second generation chip, it's basically going to enable higher definition cameras and maybe some other sensors or something. So I'll just bounce my theory off you. You can tell me what you think of this. My theory is that it'll obviously have faster. It's probably going to go from maybe it's 14 nanometer to 7 nanometer, something like that. And
I heard possibly even 5.
Okay. It's going to be, I know he said it was going to be integer 8 and Dojo is going to do floating point 16. I had a theory that it would use less power because that's beneficial for range. Although I think the current chip is already very good on using low power, very little power.
Right.
And so my theory is that Elon has decided we don't need this yet. Let's plan the 2023 compact, the vehicle that they hinted at Battery Day with the the tarp over it.
Right.
That vehicle is going to be designed for the next generation chip.
Oh, interesting.
Does that sound, because I think they designed the chip so it can be popped into the existing vehicles.
Yeah, it's supposed to be a plug-in replacement.
Right.
So
but
they can just drop it in.
If the current generation vehicles, and from what everything Elon has said, and we'll talk about Dojo in a minute, but he expects to achieve, significantly better than human, whatever that means, this year. And then Dojo comes online and Dojo is going to take it to much, much better than the best humans. And then they're sort of like, well, what's the point of getting better? I think there's a certain point where like it's so good it doesn't need to get better, but that's it'll still continue to improve. Right. But I still think, and it will have faster processing, which will enable it to handle higher definition video streams. Right. Do you think do you know much about it? Do you have any thoughts on it? Is there any gain in switching to the FSD, the new generation chip?
Well, I think that what Tesla has done is exactly what you're saying. Like at first they were saying by the end of 2021, hardware 4 or hardware 2 now, whatever the hell it is, which was going to originally be made by TSMC and designed by Tesla and Broadcom, was supposed to come out at the end of this year, and it was going to be drop-in replacement. But now they, like, just like what you were saying, Elon's been saying it's not necessary. Right. We don't need it. It's kind of more icing on the cake. So right now, I think FSD operates at about 17 frames a second. And so they could probably, if it's 3 times that speed, it's going to be 50 to 60 frames a second, which, I assume that the car will probably drive a little bit better. It might not be quite as jerky with the steering wheel sometimes or something like that. But generally speaking, it sounds like he's saying it works fine as is. The interesting part about this, of course, is that just within the last couple of days, we saw that Tesla shut down their Model 3 production in Fremont due to chip shortages. And now
I don't think they specified that it was chips.
They didn't specify
part shortage.
Yeah, they said parts, but then
was it the Samsung plant in Texas or something?
Yeah, I think part of the problem was just because of the snowstorms and stuff. But this is just a general problem with the industry right now, is that they're having serious problems with chip shortages across the board for everybody. Yeah. So that may be part of it. They may be just like, we just need to keep producing the ones that we're doing right now and not worry about making these future ones because we don't need them yet. So one thing I know is that they've switched from TSMC to Samsung. I don't know why, but in the summer, definitely all reports said TSMC was going to manufacture the chips, and they were going to do these system on wafers, which is an SoC to the next power anyway. But now they're just saying Samsung 5 nanometer, it'll come out sometime. And I think it's just because they're like, we don't really need it yet, and we don't need to be trying to go this crazy and replace our entire fleet of 1.5 million cars with hardware 4.
Well, and going along with that, Elon's been talking about it. He tweeted about this recently. Actually, I think this was I don't think I can find the tweet, but this is the tweet I was thinking of earlier. That he's been talking about going 4D. Right, this 4D change from 3D from regular.
But they're doing that with hardware 3 right now. So
but I'm wondering if switching over the entire software stack to 4D, which I think is coming in the next few weeks for FSD beta, not necessarily for you, that may actually increase processing speed. It may actually be less demanding on the chips because of the way they're structuring the software.
It's possible. Yeah. They may have found some efficiencies because right now you're right. There's the issue right now is that you've got two different modalities working at the same time. So what my understanding is there's a C++ kind of like a playpen. It's like you've got the boundaries of the playpen, which are the rules. Don't hit things, don't crash into stuff, all of this stuff. And inside of it is the neural network stuff. So if they can basically get rid of all the C++ and replace it entirely with the neural network thing, it's only one modality at that point, and it should be much more efficient than right now. So.
Right.
Yeah, they could have discovered that. I mean, maybe they've just discovered that it works better than they thought it was going to.
But so I think when they do get to the next generation chip, I think they may have reduced power consumption, which will help range a little bit, and they should have faster processing. Is there anything else you think is going to come with the next generation chip that will be material benefit to vehicle operation?
To vehicle operation, I'm not sure. I mean
everything. The recognizing objects and driving safer.
Honestly, I think a lot of the benefit will probably come with just a better user experience. Like because Broadcom is helping them, Broadcom is all about making kind of more entertainment communication chips. I have a feeling that the entertainment stack is going to get better. The Model Y that I have, and I'm assuming the Model S and X, because it has a whole separate processor, is better. But the Model Y and Model S, the graphics are kind of choppy and slow. So part of the advantage might just be that you get these ultra smooth, higher res, starts like instantaneously instead of grinding along forever, So that may be part of the advantage. But if you think about it, let's say that the hardware 3 or hardware 1 is operating at 80% max capacity all the time. So if it's a 100-watt system, it's operating at 80 watts, it's just cranking away. It's like just got 20% headroom for crazy cases. If you could take something that was still drawing 100 watts, but only needed 30% of that power at any given time because it's just so much better and more capable, then it's only operating at 30 watts while under normal circumstances, and then a snowstorm and an avalanche and a UFO hit, and it goes, then it has more headroom. So it can pump it up, but it should be able to operate at much lower operating power and temperatures.
Just excuse me 1 second. Thank you, Tactical Tesla. I got a comment here from Tactical Tesla. Thank you for your support. It says, actually, if it gets to 99%, the 1% will be a scenario that exists in one or more places on the Earth. Those places will be 100% failure. The software is scenario fail pass. Do you know what he's saying?
Could you read that one more time? Sorry.
Sure. Actually, if it gets to 99%, the 1% will be a scenario that exists in one or more places on the Earth. Those places will be 100% failure. The software is scenario fail/pass. Does that make sense to you? I think what he's saying is it'll be clear, Tactical Tesla. There's two different things here. There's the March of Nines, which is it handles 99% of situations, then it handles 99.9% of situations, then it handles 99.99% of situations. I was using a different concept of percentile, that it's better than 50% of drivers, it's better than 80% of drivers, it's better than 99% of human drivers. So I think you may be thinking about something different there. I think the March of Nines is it gets to the point, you're correct that when it's only at 99%, then 1% of the time it fails, or at least it doesn't do it right. That doesn't mean it crashes, but it doesn't do it right. But you want to get to the point where it's 99.9999% good, and then that 0.0001% stuff is really rare. And hopefully the mistakes it makes aren't fatal mistakes. They're like minor mistakes. Because, we all make mistakes on the road, right?
Right.
Where we do something wrong, but we don't crash, right? We don't crash on every mistake. Does that make sense too?
Yeah. But I also think it's an interesting idea that it's a scenario specific failure is an interesting idea, but the advantage of that is, of course, if it does fail in that scenario, that's exactly what it's going to train on for the next iteration.
Right.
So the March of Nines is kind of getting rid of all those bizarre scenarios that it doesn't know how to handle still.
Right. Okay. So let's turn to something that I'm really excited about, even though I don't really understand it.
Okay.
What is Dojo?
Boy, I wish I had better information. Okay. It's a supercomputer, but it's a very specialized supercomputer. So nowadays, I don't know, at least me being older, I have the idea of supercomputers being these giant rooms. It's like one giant computer, but that's not the case at all anymore. Of course, it's just racks and racks and racks of regular computers that are all networked together very cleverly and operate at very high speed and can process lots and lots of data. So the difference with Dojo is that they're custom designing the chips. So just like the hardware 3 or hardware 1, whatever you want to call it, that's inside the cars, there's a similar chip that they're building that they're not worried about power consumption. And like you said, instead of int 8, they're going to float 32.
I think it was floating point 16. Elon said
float 16. Sorry, yeah.
He said the gain from going to 32 wasn't that much, and the same thing with integer 8 versus integer 16. The gain from going out wasn't that much, and I think there were gains from not going to 32. Like it's
basically you can go. So they talk about 10 tops, 10 teraflops,
trillion operations per second.
Yeah. So it's actually 144, I think, for the hardware 3. But anyway, because it's running in int 8, if it was having to do float 64, it would be way slower than that.
Right.
But int 8 is fine because look at what you're doing in the car. You're pushing an accelerator pedal, a brake pedal, and turning a wheel. That doesn't require a whole lot of precision.
Right.
I mean, how many positions of your brake pedal are there? 100?
Right.
You know, it's like if you have 100 different pressures, that's plenty. So you don't really need anything past int 8 in order to process this kind of stuff. So, but anyways, so it's a specialized computing system. And the really exciting part is that they're using neural processing units, which is a specialized outgrowth of graphical processing units. So everybody's familiar with GPUs because those are in your.
Is this TPUs or is it something else?
Okay, so that's a Google specific thing, kind of. It's almost a trademark. So you've got GPUs, which are in your
graphical processing units that are in the video card that I'm using right now.
Yeah, exactly, and in my lovely phone, et cetera, et cetera. So it was discovered years ago when years ago, I mean like 9 years ago, so not that long ago, that these things were fantastic for doing neural network training. But then they're still kind of general purpose because they were designed for games first. So NPUs are neural processing units, which, by the way, because this is an iPhone 12, actually has neural processing units in it. They're specialized, so they're like a GPU, but they're specialized just for neural network training. So they're not going to play a game, Fortnite at like super high resolution or something like that. They're just a one-trick pony. They only do neural network training, and that's all. So that's what an NPU is, and that's what Dojo is going. They're building these chips specifically to have a whole bunch of those on there. Now, TPUs or tensor processing units, I believe the only company that makes those currently is Google. Okay. So they're kind of a neural processing, a tensor is what a neural network uses. It's all a bunch of high dimensional matrix math is all they do over and over and over again. So a tensor is just, if you take like a number or an array of numbers and then you make it into a matrix, like a tic-tac-toe board. And then a tensor is just when you keep increasing the dimensions. So you've got 3 by 3 by 3 by 3, whatever. So it's just a different brand name for NPU, basically.
Okay. Well, Elon referred to, we're just doing dot product math.
Mm-hmm.
So is that more of an integer thing or a floating point thing, or is it both?
It doesn't matter.
Okay.
So what that means is you've just got a column and you're multiplying it by a row or a matrix by a matrix. You multiply each of the individual things and you add them all together. And that's basically what a neural network does over and over and over again.
Okay. So let me offer my theory about what Dojo does, and you can tell me why I'm wrong. Okay.
You're probably right.
Well, no, I'm pretty sure I'm wrong. But so, or I should say one aspect of Dojo that I think could be potentially valuable. If you follow people who are making FSD beta videos, my impression is, with some exceptions, they're generally getting updates about once a week. Might be once every 10 days on average, maybe once every 7 days. So one of my theories is that, like you said, Dojo is a supercomputer. Dojo is able to do things that the current system does, let's say 10 times as fast. So if that's the case, maybe Dojo is able to send out updates once a day instead of once a week. that every time your car comes home, like currently you're getting people are getting a thing. Oh, it's, new version of FSD is downloading. They get really excited. They're getting a new version of FSD. Now it's every night your car gets updated. That's one of the things that I think Dojo could do. So it's faster, then it does everything faster, and the updates come once a day. And if you figure it's getting, let's say each update it's improving, let's say 1%. Right. Well, if you compound 7 times as fast, if you apply compound interest 7 times as fast, it gets better a lot faster.
Yeah.
So that's a theory. I don't think it's completely correct, but I think it might be part of it.
You're absolutely right. I don't know that they're ever going to be pushing these things out once a day, but the current time, this is from a lecture that Andre Karpathy did. I think it was about 14 or 15 months ago at the end of 2019. He talked about 72 hours to process one chunk of data. So it takes all of the computers that they have, like, which is a lot of computers. It takes it 3 days to go through a training sequence with all the data and come up with new predictions, new models. But the idea is that Dojo is supposed to be approximately 10 times faster. So that's 7 to 8 hours. Yeah, 7 to 8 hours. So suddenly, you're looking at being able to produce that once a day. Now, the issue with that, of course, is, and this is something as an attorney you would probably be cognizant of, they can't just keep pushing this stuff out without doing some sanity checks on it, right?
Well,
you can't break the cars. You can't suddenly make it worse.
But let's be clear. They have FSD alpha that Elon's driving.
Right.
They have FSD beta that a select group are driving, and then they have whatever is available. Let's suppose we get to the point where FSD has been released.
Right.
Okay. Elon and like 10 people at Tesla will be driving the alpha. Right. The regular folks will be driving the beta, and there's a premium group of 1,000 people who are driving the beta.
Right.
And then everybody else is driving the regular version. So I think maybe what you're saying is the people driving the alphas and the people driving the betas may need more than one day to decide whether this upgrade is better.
Yes, exactly. Mm-hmm. Yeah. There's it seems like there's a due diligence, I guess. They need to check this stuff. They can't just, I don't know. It's a different thing as a researcher for me. I can pop out a new model and I can go like, hey, let's see if this works. And it might completely break, but it doesn't matter because I'm not doing anything where a person's going to die if it breaks. So there's just an amount of steps that they still need to take. So maybe instead of once a week or 10 days, it comes down to like once every 3 days, but still it's 2 or 3 times as fast as it was before.
Yeah.
Okay. And that's the goal. The goal is for Dojo to crank through this stuff so much faster that they can iterate faster and continue to get that compound.
I suppose if it's just that it used to take us 10 days to, it took us 3 days to process it, and then it took us 7 days to test it out before we released it. Now it's okay. We process it in 7 hours, and keep in mind, I think Elon said it was 10 times faster than any other comparable supercomputer. Right. He didn't say that they currently are using the fastest one.
Right.
So it may be a more than 10x for what Tesla's experienced, but maybe it gets, like I said, it gets down to 7 hours, and that basically eliminates 2.5 days from the window of time that it takes. Right. And then maybe they're able to expand the beta group to a larger number of people, so they get more testing maybe they can shrink the window from 7 days to 4 days if they have 10,000 people trying it out instead of 1,000 people trying it out. Does that make sense as a possibility?
Yeah. And I think, don't forget that you have to always take account that it might take 72 hours to do the training, but it might also turn out to be it's like a bad run. And they're like, oops, that didn't work. So then you've got 3 more days to try again. So that's where it's if you have to do it multiple times, that's where things really start to get better.
Because in other words, if the average time they do it, it takes 3 tries.
Right. And so now you could do all 3 tries in one day. That's only 21, 22 hours. Whereas before that could be 6, 9,
let me ask you this.
days.
This is a question from Jim Whitehead, who is one of our moderators on the channel. He said, Elon said Dojo will do auto labeling of objects. How can it do this?
So that's not.
And thank you, Jim.
Yeah, sorry. That's not specific to Dojo. That's specific to what Andre is working on. It's So you've got the hardware. Dojo's the hardware, and that's going to allow the software to operate much, much more quickly. But the software itself could run on, yeah, I mean, there's a certain level of machine that it has to run on, but it could run on anything. It would just run really, really, really slowly. So it's kind of a marriage here. So Dojo will definitely allow the self-labeling to work much more efficiently, but I'm sure that the software and the technology for that is already being written, if not completely written at this point.
Okay. Oh, here's a good question for you. I'm going to go off on a tangent here.
Starlink?
No. We're still on FSD.
Okay, I know.
I would like to talk about that, but let's go. So, oh no, I think we talked about that. Let me just go with this. I think ultimately FSD, at least maybe not now, but at some point, what it's ultimately trying to do is maximize an objective function, right? I think that's what it's trying to do. So what are some components of the function? So, minimizing, so like I have this, I think I mentioned this before, that it identifies a bunch of objects. It estimates a probability of collision. It's trying to choose a path that minimizes the probability of collision. And as it's driving, it's updating probability of collision. And it says, we went over 1% probability of collision there. That's something we got to worry about. Does it make sense that it's trying to, maybe maximize is the wrong word, but does it make sense that it's trying to do something like that?
Yes, I'm not sure.
And let me be clear.
Yeah.
Some parts of the function would be getting to where it's supposed to go, right? It has a destination supposed to go
efficiently too, right? It could go 1 mile an hour and it would get there.
I got that. Maintaining a set speed that you told it to go if possible. Maintaining a set following distance, minimizing G forces on occupants, not just, it's one of the things, like people look at Teslas now and they're great high performance vehicles. My prediction is that the 2023 Compact will not be a high performance vehicle. No. If it's designed to be a robotaxi, you don't want it doing 1G operations or you want it doing very, very gentle operations.
0 to 60 in 2 seconds, and the passengers are all flat against the back.
and you want it to maximize driving efficiency, right? Because you want to be able to get the most range out of it. Do those things all sound like they would be components of an objective function? And then maybe part of the challenge is figuring out and I don't know that the dojo or the system can decide which part of the objective function is more important. I think humans may be involved in deciding which weights are more important there. Does that make sense?
Yeah. So what I understand of the system is it's called the HydroNet, which basically means that they have a subcomponent that's only devoted to stitching together all of their cameras and their sonar data and their radar data and everything into one cohesive thing that they can then start to identify objects out of. So that's one component. And then the Hydra part, so that's the body of the Hydra, and the Hydra is like that Greek mythology thing that has all the heads. And so then what happens is it splits off. If it says this is a stop sign, or this is a street light, or this is a human being, or whatever, it splits it off into all these little sub neural networks basically that are running. I think Andre said there was like 100 of them. So everything's classified into one of 100 different classes. And so basically it's two different pieces. One of them is just object detection and recognition. And then once it detects that, it puts it into the correct neural network to deal with things like ballistic probabilities and what should I do as a car? Or is that just a garbage bag in the street so I can ignore it? Or, these kinds of things.
I'm sorry, you just triggered something, and I mentioned this before. At one point in one of the things that Andre was doing, and I don't know if it was Autonomy Day or a different presentation, he talked about detecting cut-ins. That when a vehicle in the next lane is going to cut in front of you. Is there, in addition to image recognition, is there an event recognition where we start labeling events? Like some vehicle cutting in front of you, child walking out in the road?
That's where 4D comes in. And that's the difference between the old version, the version that I have right now, and the new version. And that's, I'm sure, why the new version works so much better, because it's using temporal, right? It's connecting the dots. So
currently, it's not just recognizing still images, it's recognizing things that are happening over time.
Exactly. So like my network underneath the hood, it's like at one particular frame, it recognizes that there's a human being there on the side of the road. but then in the next frame, due to whatever reasons, it goes behind a car, whatever, it just disappears. It's gone. And so it's like a little baby playing peekaboo. It's like, it's gone. It's there. It's gone. So the 4D thing allows it to connect all of this stuff together and thus to be much more coherent, right? It's like, oh, there was a person there. So I know it's still there, even though I can't see it this frame, and it's going to be back.
I heard this described in this way, and tell me if this sounds right. It sees a person, it's coming up on a bus or an object that's going to occlude there's a pedestrian and there's an object.
Right.
And it sees the pedestrian go behind the object and it's continuing to drive. And it predicts, based on what it's seen, that pedestrian is going to be in front of it's going to be on the other side of the object when I pass it. And then if it sees that the pedestrian is there, that confirms I made the right prediction. If it's not there, so it's thinking where I think that pedestrian is as I'm driving by and sort of interpreting where it's going to go. And if it sees a bus, it thinks, well, the pedestrian might be getting on the bus. Right. Because that's, it somehow starts to be able to interpret those things. So there's sort of events, and there's also sort of like it's projecting ballistic trajectories, not just I think it might be here in the next 6 frames, but it's tracking the next 25 frames thinking this is where I think this thing's going to go.
Right.
And this is the path it's going to follow.
Right.
Okay.
And like you said, it can actually error correct for that. If it makes a mistake, it can flag that.
Oh, and sorry, somebody asked a question. I just wanted to answer because I think we talked about this earlier. Somebody said, "Will the cars teach each other?" And it's not that. It's that the cars experience something that they didn't expect. This is what we roughly think. The cars experience what they didn't expect, something that didn't fit with what their model told them. They relate to the home office, the head HQ, the mothership. Hey, this was something I didn't expect. The mothership looks at all kinds of other data to try to correlate it, queries the fleet, whatever, and then sends down new instructions. And all vehicles learn from what one vehicle experiences. Right. So sorry. So I hope I didn't cut you off there. But
that's correct.
Oh, and somebody mentioned the trolley problem before, and I just want to address that. This is one of those standard moral problems. The car's driving down the road. It can choose to hit a child or it can choose to hit 5 people. That's not the trolley problem, but which choice should it make? And the practical reality is we as humans do not make those choices. We are driving down the road and we try to avoid collisions. Right. We are confronted with something. We don't make moral decisions when we're driving. Right. We have a split second to make a decision and we make a quick decision, and morality doesn't get in there. We just react based on reaction time. So it is unreasonable to expect computers to make moral decisions in place of humans when humans don't make moral decisions in those situations. And so yeah, somebody else mentioned moral decisions. We don't make moral decisions when we have short reaction time to make decisions, right?
Yeah, I mean, one thing about a moral decision is you have to mull it over for a while, and that's the last thing you have time for when you have a 1/10 of a second to make a decision of whether to turn or just keep going straight.
Yeah. Okay. So, all right, I think I'm through my outline. Oh, okay. No, I think I'm through with my outline. I think we covered I made a little outline before, today to sort of go over what I thought we would talk about. Let me just make sure I don't have anything else in here. Okay. So is there anything else that we didn't cover that you think we should talk about with full self-driving?
Oh gosh. I think the real big question is whether Elon's doing Elon time still.
Oh,
because he was so notorious for that for so long, but now it's almost like he's gone the opposite and he started sandbagging.
Yes.
Because he's like, oh, the Shanghai factory won't be open until yada, yada. And it's like 3 months earlier, it's done. He's like, they won't be making Model Ys until 2021. They're making them in 2020. So when he starts talking about them, I feel like L5 is kind of BS because that's much more of a regulatory issue than it is. Sorry, level 5 autonomy.
Right. I think for those who know, there's 5 levels of autonomy, and most of us who are into this think that they're irrelevant.
Right.
We don't talk in terms of level 5.
Right. But certainly level 5 is very irrelevant because it's a regulatory issue.
Yeah.
So in my mind, level 4 is the goal, which means that the car drives better than 99th percentile or 99.99% of the time or something, some metric. It achieves that metric, and then the rest of it is up to the law, to the legal system and the regulatory system to figure out. But I mean, Elon is pretty darn confident by the end of this year that they're going to be in a position where it's better than almost every driver.
So let me address that. Elon tweeted about there's going to be a delay before the next update to FSD beta, and it's the whole software stack is going to go to 4D. My theory is he's already driving it.
Oh yeah, for sure.
And there's 5 or 6 people or 10 people at Tesla who are already driving the Alpha with the full software stack. And they had to do some other things, and maybe that's running. Maybe some of the hardware it's running on, whatever. But whatever, they've driven it, and they still need to make sure everything's right before they release it to the 1,000 people who are using FSD beta. But he's seen it, and he can see it's better. Right. And they can see. And this is one of those things where I think I may have asked you about this before. If I didn't ask you about this before, tell me. We know about disengagements as a metric for deciding whether FSD is working well.
Right.
I think they have internal metrics that we don't know about. Like if I've actually, my video, for those who don't know, I do a Sunday live stream, and I've decided my Sunday live stream this week is going to be questions I would love to ask Elon. And I'm going to talk about the question, and then I'm going to talk about what I think his answers might be. So you can feel free to use that for yourself if you want. And one of the questions is, what internal metrics do you use to measure FSD? Right? Because we all know about disengagements, but disengagements become irrelevant when all human input is error.
Right.
So you're still going to want it to improve from that point. So, and like I think I've said to you before, minimizing the probability of collision, but I think that but you
can get much more granular than that.
Right.
I mean, down to like, if I predict to turn right 0.4 degrees in the next frame, and it should have actually been 0.3 degrees. I mean, that's an incredibly small thing that a human being wouldn't even notice, but the computers can still train on that.
Right. No, but my point is that they have internal metrics we don't know about, and they are able to measure what they're seeing with the new software stack.
Right.
And they're able to see how much it's improving. And they're able to say, it's improving much better on all the metrics we've talked about. It's improving faster. And that's why I think he said it on the Q4 call.
Right.
And there's probably lawyers in there ready to pull the choke chain on him if he says something he's not supposed to say. And Drew Baglino's right there, and he's going to say, wait a minute, it's not quite there yet. I feel like the Tesla team Drew Baglino is confident enough to say, well, wait a minute, not exactly that. He's actually gotten to that point. If you watch Battery Day, he's actually confident enough to correct Elon a little bit when Elon goes off the train.
Right.
And nobody corrected him when he said it.
Right.
So I think it's there, and I think it's that Drew's driving it, that Jerome is driving it. I don't know if Zach drives it because Zach's not an engineer, but Elon's driving it. There's 10 people on the team, and they're all like, holy, wow, this is really good. This is really,
also two other quick things to add to that. Number one, they're not just driving it. They have simulators that use real world data, so they can drive several million miles in just a couple of hours. So they can look at the statistics of what their virtual car using real world data would do in all these situations. And they can go, holy crap, this didn't have any accidents in 4.5 million miles that we just drove it.
Right.
So, and that can happen instantaneously, whereas humans take forever. The other thing was really fascinating was I thought that I was having problems with my camera pillar, the one on the driver's side, which is the little camera that looks forward, because it kept saying camera is blocked. And it turned out it was actually because I was driving the same way at the same time of day every day, and the sun was shining straight on it. But the crazy part was I contacted Tesla service. They said, please tell us the exact minute that you're having this. So I sent them like 5 incidents of that. And then they wrote me back and they said, yeah, we had something like 15 or 20,000 data points that we had to sort through over those little moments. And I was like, holy crap. So, I mean, that car is just a giant data sponge. It's just sucking down data constantly about what I'm doing and what's happening in the car, which is a little bit terrifying because it's like, man, if I make a little mistake, it's like, they know. They know if I haven't driven. So no wonder their insurance is going to be very, very particularized.
Okay. Random question. Somebody mentioned this and it triggered a question I've had. Somebody mentioned something similar. You know that they've been driving the Plaid Model S occasionally on Nürburgring, right?
Right. Oh yeah, so cool.
Could you imagine what would it take for a full self-driving to drive on the? And I just went up to Sebring International Raceway. I'm picturing they send it out onto the Nürburgring without a driver in it. Well, they sent it out with a driver in it first to watch how the human driver does it. And I could almost see that they could model that in the computer, right? They could have a model of Nürburgring, and they could send, if they send FSD in a Plaid Plus Model S or a Roadster.
Man, could it beat a human? Could it be faster than any human? That would be a fascinating
I think it's very clear that, number one, you're saving 200 pounds of weight.
Yeah, that's true. That's true.
Right? You've reduced the weight in the vehicle. I think that would be, I think we could get to a point where we have FSD racing.
Oh gosh, that's so cool.
And you know, it's not a useful thing for society. It's not going to make us all safer, but it'd be fun. It'd be fun to see
I
that.
mean, but actually it might, because think about that. If you put, say, 20 or 30 cars racing around a crazy path like that, going 200 to 300 kilometers an hour, 150, 200 miles an hour at high speeds next to each other, that's good training. Those things have to make decisions really fast not to crash into each other.
And if they crash and there's no humans in it,
right. It's like, well,
okay, they crashed, replace it with another car, move ahead.
Man, you just made me think, because I'm like, think about how many videos I've seen of Teslas of various models driving the Nürburgring. And so I'm thinking like, holy crap, they probably do have that. They probably have a simulator that they're just driving these things around constantly on. And eventually they're just going to like just send out a Plaid Model S without a human in it and go like, here, have at it.
So Matt Senkow says trivial. No, it's not trivial. It's not just to drive around the race car track. It's to drive it faster. Every time it goes around, it learns. Well, I shouldn't say that. Ideally, the car is programmed to learn how to drive the track faster and faster and faster. And because machine learning is better than human, eventually,
right?
Ultimately, it's able to perform, and it's kind of like when was it DeepMind? Some computer beat AlphaGo, something beat the best humans at Go, and it was employing strategies that humans didn't even imagine.
Right.
You could imagine where a full self-driving car would be doing the track over and over and over again, and all of a sudden it would start doing stuff. You're like, why is it doing that? And wait a minute, it did that lap faster than before. And it starts discovering. I suspect that driving is more simple than Go, and we're unlikely to see a lot of that. But it wouldn't surprise me if there was a little of that.
Right. Yeah. But the other thing is, like I said, they don't even really necessarily have to go out and drive it around and around, because they've already probably got tens of thousands of miles on that specific track that have been uploaded to. So, they've already got the training data they need, because they can see where humans made mistakes. They brake too early. They didn't apex the turn properly. They came out of the turn too late. All of those little moments that they could teach the computer. And so it could go in and just be just a perfect line all the way through it. So,
yeah. And I think, because there's a Formula E racing series. Right. Imagine a Formula FSD racing series. And here's the thing: people love the crashes. It'd be like, you could tune them to say, you don't really need to minimize the probability of crash that much. You're trying to maximize the probability of winning the race,
right?
And coming in second is no good,
right? Yeah. So if you have to nudge the other guy out of the way, no big deal.
Yeah. You can increase the probability of crash, because your goal is to get there first. And if you programmed it second place is no good, they'd probably start smashing into each other. If you're not going to win, there's some crazy ideas there.
Wow. All
right. Let me see. Let's just see if there's any questions or thoughts here. Formula FSD would be really fun.
I think somebody needs to suggest that to Elon. If somebody's one of your viewers, they need to send that to Elon.
Oh, thank you, Digital Blade California or Canada. Once you have FSD, you need to play games in your car. So let me just, if you don't, do you have some more time?
Mm-hmm.
It's okay. So I want to shift the topic a little bit to the future of robotaxi. And there's just one particular thing. This is one of the questions I would ask Elon. So I hope we could talk about this. This is something so you're designing a car, and the car is going to be a robotaxi. Okay. Right. It's not going to have a steer. Well, one interesting thing, by the way, is in the intermediate stage where it's a robotaxi, but we're going to allow some human intervention. You could use a PlayStation controller instead of a steering wheel, right? You no longer have to sit. You could sit in the back seat and control the car. You could have you could have like a port for the steering wheel and the driver's in the left side, and a steering wheel on the right side. And you don't have to make a right-hand drive, left-hand drive version. You just put ports of both sides. Right. You just pop the steering wheel over here, and you have, pedals on both sides or something, and and it just flick a switch, right? Left drive, right drive. It's in software. It's not a lever on the car.
Too crazy.
So I have this image that in the future world of robotaxi. Let me ask you a question. Have you ever been to Universal Studios Orlando?
Yeah, but it's been years. But
have you ever been to a Harry Potter section of Universal Studios?
No, I was before they opened that. Yeah.
So there's a train. There's two sections of Harry Potter land or Hogwarts or whatever at whatever they call it at Universal Studios Orlando, and they have a train. The Hogwarts train, Hogwarts Express, goes between them, and you get in the train and you sit in a car, and there's a window,
right?
And you see, some guy flying on a broom outside. It's not really a window.
That's cool.
It's an LCD screen showing you imagery of Hogwarts or a forest or, a unicorn running by or whatever.
Right.
So you design a robotaxi. Wouldn't it be cheaper to design the robotaxi with no windows?
Yeah, probably.
And then you put computer screens. You could put immersive computer screens around the rider, because they're not a driver anymore, right? It's a rider.
Right.
And he can say, I want to see what's going on outside, and the cameras show him what's going on outside. Or he could say, I want to pretend I'm flying through hyperspace, or I want to play Call of Duty, right? The new Call of Duty that takes 500 gigabytes. I want to, the person riding in the vehicle can have whatever immersive experience they want. And so one side of this, it's a better UX, right? The rider has a more interesting experience in the car. Because this goes to Digital Blade CA was saying you need to play games in the car. But the other side of this is, does it cost less to build the car if you don't have to put windows in it? I would think windows are an expensive part. Number one, they're structurally less valuable than metal, steel or aluminum or whatever. Right. And number two, and then I sort of come to this question of, let's suppose in my fantasy world, sorry for going off on my crazy tangent here. Another question I would talk to Elon about. I think the most efficient vehicle for most rides in a robotaxi world is a single passenger vehicle. And maybe you don't enter from the side. Right. Maybe you enter from the back. Because the front aerodynamic, the back's aerodynamics is less important. Maybe you step in and step over the seat and sit down in the seat, whatever the seat. I think there's a way. And then you have this shell that's structural. I don't know whether it's Cybertruck-like or whatever. Right. Wouldn't that be a much more optimal way to build a car that you could reduce? Because here's one of my goals. One of my goals in the robotaxi world is, if I can minimize the cost of that vehicle while maintaining a 1,000,000-mile life, let's say. Right. Then the less it costs, you amortize it over 1,000,000 miles, the less cost per mile. Right. And right now, I'm guessing the Model 3, Model Ys, if Tesla keeps its own, doesn't sell it to you, keeps it and runs it in its own robotaxi network, I'm betting Tesla's cost per mile on a Model 3 or Model Y is down to 10 cents or less. And when you get to the 2023 compact, it's going to be 5 cents or less. Right. But if you went to this pod car robotaxi that's 3 feet wide and 5 feet long, or whatever, half the length and half the width of a normal car, which doubles road capacity at least, because you can now fit two in a lane. The cost of making it's borderline a quarter of the size. So you're getting the cost down. You may get the cost down to $5,000 instead of $20,000. And then, you amortize that over 1,000,000 miles. It's a half a penny a mile instead of 2 cents a mile. And you can get to the point where the cost for a per passenger mile that I'm paying might be 2 or 3 cents a mile. Right. And Tesla's still making a lot of money on it. Right. So that's just a thought. Like, what do you think about this idea of we don't need windows anymore? Where we're going, we don't need windows.
Well, first of all, have you seen like Arcimoto and what's the other one?
Sorry, John Check, thank you for your support. John says FSD is worthless when snow is covering up the lines on the road. Well, we'll talk. Maybe we'll talk after we're done with this. We'll talk about FSD and weather. But what do you think about this idea?
Well, that's one of the. Let's get back to that for sure. I hadn't ever thought about not putting windows in a vehicle, but I've thought about that with spacecraft before. because human beings, because building a window into a spacecraft is structurally unsound, very, very heavy and a mess. And why wouldn't you just put cameras outside and put LCD monitors inside? And then the human can be like, oh, I'm seeing space, but they're not,
Right.
So they're looking out of that. So I guess the same would actually hold for an automobile. But anyway, the reason I was talking about Arcimoto is because they have it's a 2-passenger vehicle, but it's elongated. So you sit behind the other person, and it's just, it's just a very thin vehicle, something like that. Obviously, the use case of this would be kind of city taxis and things. You don't want to be on the highway doing 80 miles an hour in something
when you get to a full robo-taxi world and there's no human drivers and the things don't have accidents, then
that's true.
You might decide we don't need to use metal anymore.
Right.
We might be able to make vehicles out of plastics and get them even lighter weight.
Oh, scary. But it's certainly an interesting possibility.
Yeah. So about the snow, because I've seen a few people mention this. So people are saying FSD doesn't work in the snow. I've seen other people saying, yes, it does. What's your thoughts on FSD working in bad weather?
So that's the reason why L4 seems to be unattainable. If we just want to talk about that, as in, you don't need any driver intervention. It just seems so unlikely. And maybe what the cars will do is maybe they'll get to a point where they'll say like, nope, it's a blizzard. I can't see the roads anymore. I'm pulling off to the side of the road and I'm just going to sit here. Right. And I guess I could accept that, because as a human being, sometimes I've done that. Especially in Florida, geez, you get those thunderstorms in the summer sometimes, and you literally can't see 2 feet. So you just stop under a bridge for a while till it goes away. And sometimes not fighting is the best thing, the best strategy. Right. So rather than battling the rain for miles. So I guess if the car is intelligent enough to know when it's out of its depth and just kind of says like, I'm moving over for a little while, I guess that's acceptable.
Well, I think one of the theories, there's 2 different theories there. One is that the snow occludes the cameras.
Yes.
And I think Elon thinks that's a simple technical solution that they'll fix if it's an issue. As far as the snow covering the lines, I think they're pretty clear. I don't know what this particular person's experiencing. I don't think they're driving FSD beta. My impression is that full self-driving doesn't look at the lines that much. I mean, it's aware of the lines are, but it's identifying drivable space.
Right. And
it's able to determine what look, we drive without lines. Why can't FSD drive without lines? Yeah. And it has 8 cameras. We only have 2.
Right. Well, and my entire neighborhood, which is miles of road, because it's one of those stupid developments, there's not a single line in the entire neighborhood.
Right.
It's all just one big road. And so that's the reason why my non-beta version can't handle it. But clearly the beta version can handle it. It knows what a road is and what half of a road is and where it's supposed to go. So I know for a fact, like my car, I was up in Asheville, North Carolina at Christmas time, had a snowstorm overnight, and the area where the rear view mirror is, there's a little heater. And when I woke up the next morning, it was frigid outside, but that area was completely clear. So it had melted. It had kept that area where the cameras are melted.
Oh yeah.
So it didn't do it on the side pillars, but it did it on that front camera. So it definitely had that. Plus, I don't think the rear view did it, but the rear backup camera is sort of tucked underneath, so it's fairly safe from weather.
Yeah. So if they heat the cameras, that solves the problem. All right. So we're pushing 2 hours. I think you only wanted to go an hour, so we've gone a long way. I'm just going to
because I have to work tomorrow. That's all.
I'm just going to see if there's any questions. All right. So I think at this point, first of all, I want to thank John Gibbs, Dr. Know-It-All. Somebody, by the way, there was a chat comment. I loves me some Dr. Know-It-All. So just
cool.
You have fans.
Thank you all.
If you check the links in the description below, there is a link to Dr. Know-It-All's channel. Also, of course, please check out the t-shirts. There's my t-shirts. Elon, best part is no part. Check. You can check his channel for his t-shirts.
This is the Tesla bot t-shirt.
Do you also use Teespring?
No, actually, one of my Patreon supporters runs a t-shirt shop. So Dan, so shout out to Dan. He's amazing. He's done some of the designs for me and everything too. This was actually my design, so I'm very proud of it.
And I have a Patreon link for myself down here. If you check out Dr. Know-It-All's channel, he has Patreon links on his channel. This is not the type of video that he's not making any money on this video. This type of video is not a video I make much money on. So a Patreon allows us to experiment with different formats and try different things and engage in conversations that might not be as rewarding financially, but we just like doing it because I had a fun conversation. I
Yeah,
hope
me
you
too.
did too.
No, it's a blast.
So thanks everyone for watching, and I'm gonna end the stream and we'll just chat for another minute.
Yeah,
So,
cool.
Thanks everyone.
Bye-bye, everybody.
All right. So thank you very much for doing this with me.
Yeah.